In our next example, we have a Maclaurin series, so we know we're centered at 0, and we're dealing with the function sine. So now we can go ahead and look at f of x is sine. We know derivative of sine would be cosine. And then negative sine. So we're looking for a 5th order polynomial or 5th degree polynomial. So negative cosine, we're going to take derivative 5 times. Okay, so we can see a pattern here. We know that these are just going to keep repeating each other after every 4 derivatives. And then we evaluate our function at 0 at our center. So sine of 0 is 0. So all of these sines would be 0. Okay. And then cosine of 0 is 1. Negative cosine of 0 would be negative 1. And cosine of 0, 1. Alright, so we filled out our chart here. I suggest doing these this way. We write them out in this way. You can write them horizontally if you want. I think vertically works best. And then we can go ahead and put them into our format. So the first term would be 0. Second term would be 1x. Second term would be 0 there, so that's going to cancel out. Next term, now keep in mind we went first derivative, second derivative, now we're on the third derivative, so we're looking at the third power. So we're going minus x cubed over 3 factorial. We're going to skip the 4th power, and then we'll go to the 5th power. So 5th power is a 1 times x to the 5th over 5 factorial. Okay. So now, if we wanted to, we could write, I know we have a 5th order Maclaurin, but if we wanted to write the nth term, or even write the series, let's go ahead and do that. And I'm just going to give it to you, and I want you to think about it, and we can talk about it later, why it is what it is. But we have x, sorry, I'll do the x in a minute. So this, we're bouncing between negative and positive values. So we have that negative 1. We looked at these a little bit. We're going to get more into these in a little while. So alternating series. We have n minus 1 is the power of that. And then this is multiplied by x to the 2n minus 1 power. All over 2n minus 1 quantity factorial. So that would be the nth term. So that would give us each. So if we wanted to know what the 100th power was, we could do that. Okay. Last example here. So example 5, finding a power series for f of x centered at 1. And they give us a couple pieces of information. So we have an initial value. We have f of 1 equals 2. And then they give us this nth derivative evaluated at 1 equals n factorial. Alright, so let's go ahead and think about this nth term here. So if we go f prime, so first derivative evaluated at 1, this would equal, so our n value is 1 because we're dealing with the first derivative. That's going to be equal to 1 factorial. And then the second derivative would be evaluated at 1, and we're dealing with 2 because second derivative, so that's going to be equivalent to 2 factorial. And if we did the third one, you probably see the pattern already. Third derivative evaluated at 1 is going to be 3 factorial. So they give us f of 1, so our function evaluated at our center, and we know that's our first term always. So that is 2 plus our second term, we're doing our factorial. So I'm just going to write it out like this. Times x minus our center to the first power. And this is really, I think I said it before in the other video, this is really over 1 factorial. We just never write it because 1 factorial is just 1. And in the first term, we actually have a 0 factorial underneath, which is still 1. But if we go on to the next term, we're going to do this value, our second derivative evaluated at our center, times x minus our center squared over 2 factorial. And we can see what's going to happen with these factorials. We have the same thing on the top and the bottom. These are going to cancel out. So let's just do one more here. So third derivative, we have this over 3 factorial. So all these cancel out. So if we, I'll go ahead and write that. Well, I guess it's our p of x. This would simplify down to 2 plus x minus 1, and then plus x minus 1 squared, plus x minus 1 cubed. So we can see the pattern here, hopefully. If I decided to write my nth term, we could say that that would be x minus 1 to the nth power. Right. And then if we wanted to write a summation notation, a sigma notation, we go 2 plus, so our first term, plus our summation. So from n equals 1 to infinity of, I guess we don't need the fraction, because I mean you could write the n factorial over n factorial, but those are just going to cancel. So we're going to be left with x minus 1 to the nth. That would be our notation. Alright, so that's it for the video. So let me know if you have any questions and we can talk later.